Hello everyone. In these notes we're going to discuss how we can use brushes to create interactivity within D3 visualizations. So before looking into the actual syntax, let's just look at a few examples. So here I'm showing, it's actually the penguins dataset, and there are actually two scatter plots here. I just haven't bothered to add the axes, but what you can actually see are, it's the flipper length versus depth in one scatter plot, and then the beak length versus depth in the other scatter plot. The colors are the different species of penguins. So the way this works is if I highlight in one scatter plot, I'm showing the corresponding penguins in the other scatter plot. And when I move it around, it's highlighting the corresponding points in either. And I can also draw a brush in the other panel, and it's going to highlight the corresponding points. So this is actually, you'll notice it's a little bit different from in Shiny. In Shiny, when we created the same linked plot, it would have to wait for the brush to finish before it updated the appearance on the other linked plot. Here, it's actually very smooth. Anytime I move my brush, it's immediately updating the plot. Okay, so that's one example. This other example is very similar in spirit. It has two plots, and when I highlight points in the one plot, it's showing the corresponding in the other. So what this actually is doing, this is temperature versus humidity, hour by hour, for a bike demand dataset. So people are renting these bicycles, and this is the time series of bike demand for a single day. So there's the morning rush hour, and then there's the evening rush hour is when there's the most demand for these bikes. And when I hover over certain temperature and humidity ranges, I'm getting the demand for the bicycles. So you can see kind of in this range is a little bit lower demand. This range tends to be a little bit higher. Notice that the points that are being highlighted are not just the ones that are within my brush right now. The reason it's doing this is because it's selecting, each point is 1 hour across all day. And if I highlight 1 hour, it's going to select all the points for all the hours for that day. So here this must have been like a particularly warm day. And these are all the hours associated with that one very warm day. And as soon as any one of the points for that day fall into my brush, I'm highlighting all those points, all those hours. Okay, so these two examples, they're basically ways to use linked plots to do some sort of filtering, some sort of focus plus context. Now, a different way to implement focus plus context is to change the scales. So in this example, here's like a mini version of this data set. And what I can do is I have a brush, and the brush is only defined on this mini version. Notice the crosshairs appear when I'm on this side of the plot, but the crosshair don't appear when I'm over the main plot. And when I brush over any subset, you see it's kind of zooming in. So if I really care about this like top right corner, I draw the brush over this top right corner, and now here are just those points that lie within the brush, but all zoomed in. Right, so you can kind of use this to inspect just some small parts of my very large plot, right? So two different kinds of uses for brushes. One is to link plots, the other is to do a certain kind of zooming. So those are the use cases. How do we actually implement these? So we already discussed how to create brushes in the previous notes. Remember, you can use this d3.brush command. d3.extent is saying, where should the brush appear, right? In some of these, I don't want the brush to appear on the entire SVG canvas. I only want it to appear on some smaller part. Right? Maybe it's just one of the plots that I want the brush. Right? Now, that's how you create the brush. What do we usually do with the brush afterward? We typically need to figure out where is the brush, and we need to update some sort of selection based on that. So this is from the bike example. You can read the entire code in the link at the top. But what it's doing is every time the brush is moved, I call this brush update command. And when I call brush update, it's trying to figure out what are the days that are currently underneath my brush. To figure out those days, I'm first getting the coordinates of the minimum, maximum x, so the minimum, maximum x for my brush, the minimum and maximum y for my brush. And I get that from the event selection. A different way to get the minimum and maximum x and y for the brush is to use a function called d3.brushSelection. So there are just two different ways of getting brush information. One is based directly on the event, and the other one you can figure out based not on an event, but on the SVG selection. So this is the approach that I use in the penguins example. This is the approach I use in the bike example. Okay. So that is how you get the coordinates. Once you figure out those coordinates, you can use them however you want. So in the bike example, I'm using those coordinates here to map it back into the x and y space for the data, right? So remember, these are all in pixel coordinates. That's not very useful for defining a query on the data object, right? The data object values, they're on a totally different scale than the pixel coordinates. So I'm using scales.invert. Almost all the linear type scales will have some sort of inversion function where when I pass in the pixel coordinate, it will give me the corresponding original data coordinate, right? So like in either the penguin or the bike example, if I have some pixel coordinate, it will tell me this is the corresponding flipper length or the corresponding beak depth for this minimum x, maximum x kind of thing, right? So once I get in the original data space, I can use those coordinates in the data space to define some sort of filter. So in this code, I'm just going through date by date, right? And then figuring out is the temperature, right? The temperature or the humidity for that particular time point, does it belong to my brush? If it does belong to my brush, then I select that entire date. And that's what I'm going to eventually use to update the appearance in the final updated view. And I'm doing something very similar in the penguins example. I'm just checking I'm inverting into the data space, and then I'm checking penguin by penguin. Do you belong within the bounds defined by the brush? Okay, so here's an example showing you don't necessarily have to do the kind of selection that I've defined above, right? So before I was showing if you fell in the one brush, you were going to be highlighted in the other. Here I'm defining two brushes, and the way it's working is it's doing a kind of intersection. So I'm only highlighting the samples which lie both in this brush and in this brush. Right. So just trying to show that you actually have a lot of flexibility in what you highlight and how the visualization responds to any of these interactions. So those are both kind of dynamic linking and kind of selection highlighting type operations. What about this last one that we had shown, the one with the zooming? The way this works is a kind of trick. Every time I move the brush, what I'm actually doing is I'm changing the scale that defines the locations of these points. You can think of it as when I have the full dataset in view, kind of it maps the very low values here, high values here, but then all those are contained within the canvas. When I zoom in like this, it's adjusted the scales so that this very minimum pixel coordinate corresponds to that particular data x coordinate. Right. So the way I'm getting this kind of stretching and compression type operation is by just changing the domain of my scale. Right. When the domain is really narrow, then it looks like the plot is very stretched. And when the domain is very wide, it looks like the plot is kind of more spread out, or sorry, more compressed. And that's exactly what's going on here. Right. So first I get the coordinates in the data space of my brush. This is just like before. But once I have those coordinates, I recreate the scale, right? So I always have this make scales function, but instead of using the width of the entire canvas, I limit my domain to just where the brush currently is. And I also limit the Y domain to just where the brush currently is. Once I've updated my scales, I can change my locations of all the circles using that new scale. Okay, so we've covered different ways to use brushes. There's a lot of flexibility here. The main things to know, you can define the brush using d3.brush, right, just like here. And once you have the brush, you can use the pixel coordinates to define different kinds of selections and different kinds of rescaling. So the selection you can do by getting the event selection and then do any kind of data processing based on that selection. And then the rescaling you can get just by redefining the scale and regenerating the plot with the updated scale.